Hi everyone, and welcome to part 1 of our new series on the electrical activity of the heart. In this series, we'll explore how electrical impulses are generated and spread through the heart to coordinate every heartbeat. We'll start in this video with the cardiac conduction system, the pathway that carries the signal through the heart. Then in the next parts, we'll look at how the pacemaker cells of the SA node generate spontaneous impulses, how the cardiac muscle cells respond through their action potentials, and finally, how all of this electrical activity appears on an ECG. Let's begin by following the conduction pathway step by step. It all starts here, in the sinoatrial node, or SA node. Located in the upper wall of the right atrium, the SA node acts as the natural pacemaker of the heart. Its cells have automaticity, meaning they can generate electrical impulses on their own, without any external stimulation. These impulses set the rhythm for the entire heart. From the SA node, the impulse spreads through the walls of both atria. As this wave of depolarization passes, the atrial muscle contracts, pushing blood from the atria into the ventricles. This ensures the atria contract first, before the ventricles. Next, the electrical signal reaches the atrioventricular node, or AV node, located at the junction between the atria and the ventricles. Here, the impulse slows down for a brief moment. This short delay is essential because it gives the ventricles time to fill completely before they contract, ensuring efficient pumping. I just want to clarify that when I say the impulse slows down in the AV node, I mean the speed of conduction slows, not the rate of firing. The SA node still sets how often impulses are generated. It's like sparks traveling down a fuse. They're produced at a steady rate, and even if they enter a thicker section of fuse where they move more slowly, the rate at which they enter that slow section doesn't change. The AV node only changes the speed, not the rate. After passing through the AV node, the impulse enters the bundle of His, a narrow pathway of conducting fibers within the interventricular septum. The bundle of His serves as the only electrical connection between the atria and the ventricles. The impulse then divides into the right and left bundle branches, which carry the signal down the two sides of the septum toward the apex of the heart. This ensures both ventricles receive the signal almost simultaneously. Finally, the signal spreads through the Purkinje fibers, a network of specialized conducting cells that distribute the impulse throughout the ventricular walls. This triggers rapid, coordinated contraction of the ventricles, pumping blood out to the lungs and the rest of the body. Within a fraction of a second, the entire heart has contracted in a smooth, synchronized rhythm. So let's summarize the conduction pathway. The impulse starts at the SA node, spreads across the atria, pauses at the AV node, travels through the bundle of His, continues down the right and left bundle branches, and finally spreads through the Purkinje fibers. Together, this conduction system ensures that the atria contract first, followed by the ventricles, producing an efficient, coordinated heartbeat every time. In our next video, we'll take a closer look at the pacemaker potential to understand how the SA node generates these impulses automatically and keeps the heart beating rhythmically. Thanks for watching, and I'll see you in the next video.